Okay, so now we're going to see how we can use trig ratios to find missing sides and missing angles in right triangles. So you always have to have a right triangle, meaning a 90-degree triangle, for this to work. You can only use SOHCAHTOA, our trig ratios, if you have a right triangle, a 90-degree angle, because the side across from the right angle is the hypotenuse. So unless you have a right angle, you don't have a hypotenuse, and then you don't have the other sides either. So remember our three trig ratios: sine of theta. By definition, the sine of the angle theta, that ratio is the length of the side opposite theta divided by the length of the hypotenuse. That is the SO part of SOHCAHTOA. The cosine ratio, that's a name given to that ratio. It's the length of the adjacent side divided by the length of the hypotenuse. That's the ka part of SOHCAHTOA. And the tangent of an angle theta is the ratio of the side opposite to theta divided by the length of the adjacent. That's the TOA part. So remember, these angles theta are either of the two angles that are less than 90 degrees. We never work from the 90-degree angle. It's always from one of the other two angles in the right triangle. So we can use this in order to find missing sides and missing angles in right triangles. So the example says, find x or y in the following triangles, round to the nearest tenth. So here's how we start these. The same way we started those ones the last few days. We label the sides of the triangle. The side across from the right angle is always the hypotenuse. That never changes. So that's what we start with. Okay, Jaden, you with us? Now, if you look at that triangle, you're given this angle to be 33 degrees. We're going to use that. That's theta. So the side across from that is the opposite. The third side is the adjacent side. This is always our first step. Label the sides of the triangle. In this case, we are trying to find x, which is the opposite side. We're given 6.5, which is the adjacent. We're going to use the opposite and the adjacent here. So I'm drawing a shape around them to show that those are the two that we're going to use. We're not given the hypotenuse. We're not asked to find it, so we're not going to use it. We're going to use the opposite and the adjacent. And if we look above, the only ratio that uses opposite and adjacent is the tangent ratio. Sine uses opposite but not adjacent. Tangent uses adjacent but not opposite. The only one that uses the opposite and the adjacent sides is the tan ratio. So that's the ratio we need to use here. And now we're going to write an equation. The tangent of theta. Theta refers to the angle. In this case, the angle is 33 degrees. That's the angle theta. We're given it. And by definition, tangent is opposite over adjacent. So x is the opposite. That goes on top, divided by the adjacent, which is 6.5. So this is key. You look and see which two sides you're using. That tells you what ratio you need to use. And then you need to write an equation. And the tangent ratio is the length of the opposite divided by the length of the adjacent. So the tangent of the angle, which is 33 degrees, is the opposite x divided by the adjacent 6.5. So the right side is a fraction. We're going to make the left side a fraction as well by putting it over 1. When I say left and right side, I'm talking on either side of the equal sign. And the reason I'm doing this is now because we have two fractions equal to each other, we can cross multiply. Their cross products are equal. I'm going to start with the pair that has the x. 1 times x equals 6.5 times tan of 33 degrees. So when you cross multiply, that's what we're left with. I cross multiplied. So the pieces that are diagonally across from each other are multiplied together. So the 1 on the bottom left times the x on the top right is x. 1 times x is x. And that must equal the 6.5, which is on the bottom right, times the tan of 33, which is the top left. Now you can do those two in either order. You can go tan 33 first times 6.5 second, or the way that I did it. The reason I did it this way, I'm going to show you. Remember yesterday we said your calculator has to be in degree mode for this to work, and mine is. So I'm going to go 6.5 times the tangent of 33 degrees is 4.2. That's our answer for x. That's what you should get if you're doing it on your calculator. 6.5 times the tangent of 33 degrees is 4.2. Okay, so there's x, approximately 4.2, and that would be in feet because the adjacent side is in feet as well. So I said you can multiply those two in any order. However, you got to be careful, because if you just go tan of 33 times 6.5 like that, you don't get the same answer. And the reason for it is, if you're going to do them in that order, you have to put the 33 in brackets. When you hit the tan of 33, a bracket opens. We're going to put the angle 33 degrees in there. You must close the bracket and then multiply by 6.5. And that'll give you the answer of 4.2 that we needed. The previous, where I didn't close the bracket, it multiplied the 33 by 6.5 and then took the tangent of that value. That's what it did. Okay? So that's why it gave us the wrong answer, because it didn't just take the tangent of 33. So if you do that in that reverse order, you have to make sure you close the bracket after the angle. Okay, let's look at question B. We start by labeling the sides of the triangle. The side across from the right angle is the hypotenuse. That never changes. We're given this angle in the bottom right-hand corner to be 28 degrees. That's the angle we're going to use. So the side across from that is the opposite. The third side is the adjacent side. This is no different than what we did over the last couple days. Next, which two sides do we need to use? Well, we want to find x, which is the opposite. We're given the 31.5, which is the hypotenuse. Those are the two sides we're going to use. We're not given the adjacent side. We're not asked to find it. We're not going to use it. We're using the opposite and the hypotenuse. And if we look above, that's the sine ratio. Only sine uses opposite and hypotenuse. Cosine uses hypotenuse, but not opposite. Tangent uses opposite, but not hypotenuse. Only the sine ratio uses opposite and hypotenuse. So that's what we must use here. So we can write our equation. The sine of the angle, which is 28 degrees, by definition, equals the opposite, which is x, over the hypotenuse, which is 31.5. So there's our equation. So the right side is a fraction. We're going to make the left side a fraction as well by putting it over 1, or putting a 1 underneath. Whenever you have two fractions or ratios that are equal to each other, their cross products are equal as well. So we're going to cross multiply. So the 1 on the bottom left times the x on the top right, 1 times x is just x, must equal the 31.5 on the bottom right times the sine of 28 degrees on the top left. Whenever two fractions or ratios are equal, their cross products are equal. And so when you cross multiply, this is what we get. X can be found by going 31.5 times the sine of 28 degrees. To the nearest tenth, the 1 decimal. The 7 is in the first decimal place because a digit to the right of that is an 8. That means a 7 has to go up to an 8 as well. Approximately 14.8 is our answer. And that would be in centimeters because the hypotenuse is in centimeters. Surveyors use trigonometry all of the time because they can measure distances without actually running a tape measure. Surveyors use trigonometry all of the time. Okay? If you want to find the distance across a river, you can use trigonometry in order to calculate that. It takes a couple tools. You have to do a little bit of measuring, but it's impossible to run a tape measure across a river unless you're a really good swimmer and you want to drag it over there. Okay? Surveyors can use trigonometry to find the distance across a river. They can use trigonometry to find the height of a tall object, like a big tree, or a house, or a building, or a mountain. You can use trigonometry to find the height of those things. You just need a couple measurements, and you can do it, just like we did here. That last example, here. There we go. So that last example, you can imagine that that triangle represents the height of an object. Okay. Now, it probably wouldn't be in centimeters, it'd be in feet or meters probably. But you can imagine that that triangle represents, let's say, the height of a tree that you're trying to find. This angle, 28 degrees, would be known as the angle of elevation. It's the angle a person is standing some distance away from the base of that tree, and the angle that you have to shift your eyes between looking straight at the tree and looking up to the top of the tree is 28 degrees. Surveyors have a tool that measures those types of angles. It's called a clinometer. Okay? And they know that they are 31.5 units away from the top of the tree. They can use trigonometry to calculate the height. Okay? And we will look at some examples later on where we're solving problems, finding the length of distance across a river or the height of something using trigonometry. So let's continue on this next one. We start by labeling the sides of the triangle. Side across from the right angle is the hypotenuse. That's what we're trying to find in this case. You're given this angle to be 44 degrees, so you're going to use it. The side across from that is the opposite. The third side is the adjacent side. That's always our first step. Label the sides of the triangle. Next, we need to figure out which two sides we're going to use. We want to find the length of y, which is the hypotenuse. We're given the 10.2 feet, which is the adjacent. Those are the two sides that we're going to use. The adjacent and the hypotenuse. And if we look above, cosine is the one that uses adjacent and hypotenuse. That's the only one that uses those two sides. Sure, sine uses hypotenuse, but it doesn't use adjacent. Tangent uses adjacent, but it doesn't use the hypotenuse. It uses the opposite and the adjacent. In this case, we need to use cosine because that's the only one that uses adjacent and hypotenuse. And you have to follow the definition. The cosine of the angle, which is 44 degrees. By definition, it's adjacent on top, hypotenuse on the bottom. The adjacent, which is 10.2, divided by the hypotenuse, which is the letter y. You have to follow that order. Otherwise, you'll get it wrong. So like we did the last one, we make both sides a fraction by putting a 1 underneath that cos of 44. Whenever you have two fractions or ratios that are equal to each other, their cross products are equal. This one's a little bit different than the last two because in the last two, when we cross multiplied, we got x by itself. We got the variable by itself. That's not going to happen this time. When you cross multiply, it's going to be y times the cosine of 44 degrees equals 1 times 10.2. The difference here is that when we wrote our ratio, the variable y was on the bottom. If we look above, in both cases, the variable x was on the top. And so when we cross multiplied, we had x by itself after that one step. In this case, because the variable y is on the bottom, when we cross multiplied, we don't have y by itself. We have to do one extra step here to get y by itself. Because the y and the cos of 44 are hooked together by multiplication, that extra step will be dividing both sides by the cosine of 44 degrees. Sometimes we have to do this extra step to find our answer, to get, in this case, the variable y by itself. Okay, so we did that. We divided both sides by the 10.2, or by the cos of 44, and now we have y by itself. And so we can use our calculator and go 10.2 divided by the cosine of 44 degrees. So it just so happens that this answer is very close to the last one. It's 14.2 rounded to the nearest tenth. The digit in the tenth place is a 1. To the right of that is a 7, which means the 1 has to go up to a 2. Right? And that will be, in this case, that'll be in feet, because the adjacent side is in feet, so our hypotenuse will be in feet as well. So there's the answer to that one. Looking at the next one. First step, label the sides. Our right angle's at the top here. The side across from that is the hypotenuse. We're given this angle of 46 degrees, so we're going to use that. The side across from that is the opposite. It's opposite to or across from the angle we're using. The third side is the adjacent side. That's always our first step. Next step, figure out which two sides we're using. We want to find x, which is the adjacent. We're given the 10.45, which is the opposite. Those are the two sides that we're going to use. We're not given the hypotenuse. No, we're not asked to find it. Not going to use it. So the ratio that uses opposite and adjacent, that's the tan ratio. That's the only one that uses those two sides. Okay, sure, sine uses opposite but not adjacent. Cosine uses adjacent but not opposite. The only one that uses opposite and adjacent is the tan ratio. And the order matters. It's opposite on top, adjacent on the bottom. You have to follow that order. So the tangent of our angle, which is 46 degrees, equals the opposite on top divided by the adjacent on the bottom. Okay, we make the left side a fraction to match the right side, so we can cross multiply. Whenever two ratios or fractions are equal, their cross products are equal. And once again, when you multiply the x by the tan of 46, they go together, and that equals on the other side the 1 times the 10.45, which is 10.45. We do not have x by itself. We have to do this one extra step to get x by itself. Because the x and the tan of 46 are hooked together by multiplication, we divide both sides by tan of 46. So the tan of 46's cancel on the left. We now have x by itself. And we go to our calculator, punch it in, 10.45 divided by the tan of 46, and we have our answer. The digit in the 10th place is a 0. To the right of that is a 9, so the 0 goes up by 1. We get 10.1. And our units here are centimeters. Okay? You do the same thing every time. Start by labeling the side. Start by labeling the hypotenuse. The side across from the angle that you're working with is the opposite. The third side is the adjacent. Check and see which two sides you need to use. It's based on what you're given and what you're trying to find. That'll tell you what ratio you have to use. Write your equation. Make both sides a fraction, cross multiply, get x by itself, or y, or whatever the variable is. It's the same thing every time. And if you practice, if you do this, practice the homework, the more you do, the better you're going to get at it. Like everything else that we've done. Let's look at question B. Let's do that one together. First step, label the sides. The side across from the right angle is the hypotenuse. That's our 10.7. That's the side directly across from the right angle. We're given this angle at 22 degrees, so we're going to use it. The side across from that is the opposite. The third side is the adjacent. This is how we've always labeled our triangles. Start with the hypotenuse. Then look and see which angle you're working with. Side across from that is the opposite. Third side is the adjacent. In this case, we use the opposite and the hypotenuse. We're given the hypotenuse. That's our 10.7. We're trying to find the length of y. That's the opposite side. Those are the two we're using. We're not given the adjacent, nor are we asked to find it. So we're using the opposite and hypotenuse. And remember, SOHCAHTOA tells you what the three ratios are. The one that uses opposite and hypotenuse is the first one. The S stands for sine. We need to use the sine ratio here. That is the only one that uses opposite and hypotenuse. And the order matters. The sine of the angle, which is 22 degrees, equals O comes before H. So it's O, the opposite on top, H, the hypotenuse on the bottom. Opposite is Y, hypotenuse is on the bottom. Make both sides a fraction. Cross multiply. And in this case, when you go 1 times Y, you've got the variable Y by itself. That will equal 10.7 times the sine of 22 degrees. When you cross multiply, the cross products are equal. So you go in your calculator, and in this case, when you cross multiplied, you had the variable by itself after that step, because the variable y was on the top of the fraction. We saw in the last two examples when the variable's on the bottom, you have to do that one extra step. In this case, we don't have to, though. Our answer will be approximately 4 inches. And you know, it never hurts to look back and make sure your answer is reasonable. The hypotenuse is always the longest side of a triangle. Always. So we know that we would have had to have got an answer less than 10.7, and we did. So our answer is reasonable. Okay, go back and try A on your own, then we'll check it. Start by labeling the sides. The side across the right angle is the hypotenuse. You're given that 30-degree angle in the bottom right-hand corner. The side across from that's the opposite. Third side is the adjacent. So that's the first step. You should have labeled them just like that. That's the only way you can label this. based on what we're given, and what we're trying to find. Then we're using the opposite and the adjacent here. We're trying to find x, which is the opposite. We're given the 4.6 centimeters, which is the adjacent. We're not given the hypotenuse, not asked to find it. So we're using opposite and adjacent, and if we look above, that's our tan ratio. Only the T uses the O and the A. Tangent uses opposite and adjacent. And the order matters. It's O first, A second. Opposite on top, adjacent on the bottom. So when we write our equation, we would say the tangent of our angle, which is 30 degrees, equals the opposite, which is x, has to go on top, over the adjacent on the bottom, 4.6 centimeters. Your equation must look like that. Has to be that way. You follow the order that you're given. Make the left side a fraction, cross multiply. 1 times x equals 4.6 times the tan of 30 degrees. And two ratios or fractions are equal to each other, their cross products are equal. 4.6 times the tan of 30. And if you're doing this and you're not getting the right answer, it either means you're not putting the things in your calculator correctly, or maybe you're not in degree mode. We went through that yesterday. So rounding this to the nearest tenth, the digit in the 10th place is the 6. To the right of that is a 5, which means a 6 goes up to a 7. So it's approximately 2.7 centimeters, which is a reasonable answer. We said that the hypotenuse is always the longest side. The other thing we know about triangles is that sides are proportional to the angle across from them. The bigger the angle, the bigger the side across from it. The smaller the angle, the smaller the side across from it would be. So that 30-degree angle is quite small, so the side across from it would have to be small as well. And it is. It's smaller than the adjacent side that we were given. Okay, looking at question C. Start by labeling the sides. Your right angle is in this bottom right-hand corner. The side across from that is the hypotenuse. You're given this angle up here to be 28 degrees, so you're going to use that. Side across from that is the opposite. Third side is the adjacent. Triangle must be labeled this way. In this case, you want to find x, which is the adjacent. The 42 is given to us. That's the opposite. We're using the opposite and the adjacent, which is the tangent ratio. Only tangent uses opposite and adjacent, O and A. And the order matters. It's opposite first, adjacent second. Opposite on top, adjacent on the bottom. The tangent of the angle, which is 28 degrees here, must be opposite on top, adjacent on the bottom. So in this case, we have our variable x on the bottom, which means after we cross multiply, we're going to have to do one extra step. But first, we got to make the left side as a fraction so we can cross multiply. And I always just start with the pair, the pieces that has the variable in it. It's x times tan of 28 equaling 1 times 42, which is 42 centimeters. And like I said before, we do not have x by itself. We have to do the one extra step. Because the x and the tan of 28 are hooked together by multiplication, we do the opposite, which is divide. Both sides by tan of 28. So on the left, when you divide tan of 28 by itself, it cancels. You'll get 1x or just x. And on the right side, we'll get our answer by going 42 divided by the tan of 28 degrees. So it's a much larger number than we've seen before. The digit in the 10th place is a 9, and to the right of that is also a 9, which means this goes up. 78.99 rounded up would be 79 centimeters. So x would be approximately 79 centimeters, which is a reasonable answer. If we look at that x, it's a much larger side than the 42, so it's going to have to be greater than 42. The 42 is across from a 28-degree angle, so that 28 would be the smallest angle. It's opposite the smallest side. The adjacent side would have to be bigger. Okay, try that last one on your own, and then we'll check it. Side across from right angles of hypotenuse. They're given the 64-degree angle, so you're going to use that. Side across from that would be the opposite. Third side is the adjacent side. So it must be set up this way, based on what you're given. Then in this case, we have to use the adjacent and the opposite. You want to find y, which is the adjacent side. You're given 9, which is the opposite. You're not given the hypotenuse, not asked to find it, not using it. So you should be able to finish it off from there. Make sure you figure out which equation you need to use, which ratio, write it, and then solve for y. So the only one that uses opposite and adjacent is the tangent ratio. The tangent is 64 degrees equals, and the order matters. The toe apart tells us it's O first, A second. Opposite on top, adjacent on the bottom. So the variable y will be on the bottom. We make both sides a fraction, so we can cross multiply. And in this case, when we multiply the pieces that are diagonally across from each other, it'll be y times the tangent of 64 degrees equals 1 times 9. We do not have the variable y by itself, so again we have one extra step to do, and that is to divide both sides by the tangent of 64. So when you divide on the left the tan of 64 by itself, you'll get 1. 1y or just y. And to find out the value of y, we need to go 9 divided by the tan of 64 degrees. So the digit in the 10th place is a 3. To the right of that is an 8, which means the 3 has to round up to a 4. So approximately 4.4, and that would be just no units given. Just 4.4. There is no unit on the 9. It's 9 units, so our answer will be 4.4 units. Okay? So I'll hand out the assignment. Do it. Do the assignment. I will post the answers on Google Classroom. Do the practice. Check your answers on Google Classroom. Make sure you're doing them right. If you do the practice, you're going to do better on your quizzes and your tests.